let's get down to business. How do you graph logarithmic functions? Well, first let's start out with a basic looking logarithmic function and see how this looks on the graph. Now, what I want you guys to think about is, like this as like a normal equation. But what you have to do with this bad boy is you have to solve for x. Because, quite frankly, if you're new with solving logs, it's hard to think about what you want to plug into this x right here. So what I want you to do is I want you to solve for the x. And in doing that, you're going to change it into exponential form. And then it'll be easier to create a table. Okay, check it out. So how do I get this x out of the logarithm? What is the inverse operation of log base 3? We talked about this yesterday. It was a property. Base 3. You raise it to the base 3. So we're going to go base 3, base 3. Now this is an exponent right here, and this is an exponent. Okay? And so you would write it out like this. 3 raised to the y power equals, and when they have the same bases, they cross out because they're inverses, equals what? X. Oh, it looks so much prettier. So which values would you pick? Would you pick x values or y values to plug into this? And that kind of makes sense because logarithms are inverse operations to exponential functions, which is why we have the x and the y kind of switching places here. So we'll just pick -1, 0, 1, and 2. So after I pick my y's, and I pick my y's because it's an inverse operation, it's easier for me to see. I plug in -1 to the y, so I get 3 to the -1 equals x. What is my x? 1/3. Okay, I plug in 0. What is my x?
1.
Is 1. If I plug in 1, I get 3. If I plug in 2, I get 9. Then I graph it. So I go to 1/3, -1. 1/3 is about right there, and I go down to -1. And then 1 it goes to 0, and 3 goes to 1, and then 9, which is way over here, goes to 2. This line will never ever cross the y-axis. The y-axis is your asymptote. Can I pick a y right here? Can I pick a y that would make the x negative? No, you can't. Remember, we kind of did this with the exponential function. You cannot pick a y to get on this side with the negative x, which is why we have a wall right here known as the asymptote. Now, what is this asymptote? How would you define it? X equals. Very nice. Yeah. Okay, trying to catch you guys there because last time it was y equals. For exponential functions, it's y equals. For logarithms, it's x equals. What's my range on this one? Well, I look at the y-axis for my range. I look down and see, okay, how far is this line going to go down? Oh, it's going to go down forever. So my lowest number is -infinity. I look at this end right here, and it's pointing to the right and it's pointing up. It's going up. And so what is the highest range number? Well, positive infinity. There's no bound here. The domain has a bound. What's the lowest? What's the bound 0. On the low side? Yeah, 0 because of the asymptote, and it goes to positive infinity. So now for this one, we got this crazy looking guy. There's lots of stuff happening to this logarithm. There's shifts going on. We have that +1 right there. That +4 right there. Just really quickly, do you guys think you know what that +1 is going to do to our function? Shift it which way? Left. And see, if you're good at that, then you might really like the parent-child way. But there's a lot of things that you have to see and understand about, like changing the table, the child table versus the parent table. But I really think you like this inverse way of doing it. And so let's start off with our function as an equation. Log base 5 of x plus 1 plus 4. So our job here, just like before, is to solve for the x. How am I going to get that x alone? Well, right now that x is inside this logarithm. Now, one error that you might want to make, but don't make it, is you want to raise it to base 5 right away. But the problem with that is this +4 is not in the logarithm, and so you will not be able to cross out. You will not be able to cancel this out because this is with the +4. So to solve our problem, what are we going to do? Peace out, 4. Don't want you there no more. So we have y minus 4 equals log base 5 of x plus 1. Now, the next thing for me to do is to get the x plus 1 out of the logarithm. What is the inverse of log base 5? Raise it to the base 5. So I raise it to the base 5. Peace out, logarithm. You ugly. And I'm left with x plus 1 on the right side. And on the left side, I have 5 raised to the y minus 4. Oh, now it looks like our exponential friend. And to get the x alone to finish the job, we're going to subtract 1 from both sides. And so that it looks like this. 5 raised to the y minus 4. I'll put parentheses around it just for looks. Minus 1. Alright, cool. We're going to use this guy to make our table. Now, because we're working with logarithms, which values are we going to pick? The x values or the y values? Yeah, I would hope so. We just solved for x, and let's find the y's that we're going to pick. Now, you can't just pick any y, because look what happens. Let's say I pick -1, right? That'll be the first one you pick. What happens if I pick -1? Something not pretty. We have 5 to the -1 minus 4 minus 1 equals x. Well, what is 1 minus 4? It is 5 to the -5. Ugh. Minus 1 equals x. 5 to the -5, that's 1 over 5 to the 5th power. Minus 1 equals x. What is 5 to the 5th power? Well, I think it's 625, but I don't. That's just off the top of my head. I might not be right. But that's a really small number. I have to take 1 over 625 and subtract 1 from it? Let's not do that. I don't want to pick -1. Now, you could do that if you really want to and you're weird. But let's think of a y value to pick that would make a pretty number. Because we all like pretty things.
4.
You guys want to start with 4?
Yeah.
Alright, we'll start with 4. Okay, if I plug in 4, what would happen? I have 5 raised to the 4 minus 4. Now I subtract 1 from that equals x. 4 minus 4 is 0, so I have 5 raised to the 0 power. 5 raised to the 0 power is? Uno. And so I go 1 minus 1, which equals 0. Alright, give me another. 5. So I plug in 5. Let's see. Oh, I need more space here.
Don't touch my way.
I'll try to do math problems. So I go 5 raised to the 5th power minus 1, 4 minus 1 equals x. 5 minus 4 is 1, minus 1 equals x, and so I get 5 minus 1, which equals quattro. Alright, give me another y. I need like 3 more y's. 3? Ooh, 3. Huh, I like that one. See, 5 raised to the 3 minus 4. See, that's not bad. Do you know why? Because now we get 5 to the -1. Oh, that's not that bad. I mean, it's a fraction. Not really excited about it, but we get 1 over 5, and then we could change this 1 to be 5 over 5 to get our x. So 1 minus 5 is going to be -4, so we have -4 over 5. That's not terribly bad. At least we got some kind of a negative number in there so we can see what happens with our graph, and that's kind of like what you want to do. You want to have some kind of a negative number. Give me another y value to pick so I can be done here. No, not 10. That 10's not going to work. Oh, it's going to work, but it's going to be off my graph. Let's try 6, because we were increasing there. So if I plug in a 6, it'll go like this. It'll be 5 raised to the 6 minus 4 minus 1 equals x. 5 raised to the 2 minus 1 equals x, and 5 raised to the 2 is 25 minus 1, so we get 24 for our x. So, let's graph it. To graph it, I first go 0 to 4. Let's see. 4 raised to the 5th. No. Okay, and then the next one would be 4, 5. So I'll go 1, 2, 3, 4 up to 5. Next one's going to be -4 over 5, which is not quite -1. It's right before it. Down to, up to 3. That's 1, 2, 3. Okay, and then the last one's 24, 6. Unfortunately, that's not on our graph because I only go up to 10 right here. So when we graph it, it looks something like this. And the reason why it stops right there, I mean, one reason why, well, we had the asymptote. One way to find that out is because of the plus 1. The plus 1 shifts it to the left once, and so we have x equals -1 instead of 0 like our other dude that we just did. The range, -infinity to +infinity, and the domain, What's my lower bound this time? -1, and then it goes to positive infinity. See, -1 is right there. It will not cross -1. That's how you graph it.